Hello everyone. This video is about assignment on system design through Verilog. This is week 6 assignment, and in this I'm gonna be focusing on these last 4 questions. So let's get started. I have already done some homework on this question, as you can see, and I have the answers too. I just want to explain how did I got this answers and what was my approach to this. So they have mentioned that we have two SR flip-flops whose outputs are C and D, and there are two inputs A and B. So let me draw those flip-flops and whatever the information they have given. Let me pull out some other page. So they have given me two flip-flops. So one of the output is C and another flip-flop which is having D as output. So there are two inputs A and B here as well, but we need to design some combinational circuit that can give us the output as mentioned, as specified in the question. So what are those specifications? So first thing, they have mentioned that if A is 0, circuit remains in the same state. So, and it doesn't even depend on B. So what they are saying is, if I have two inputs A and B and A is 0, it doesn't depend on B input. So this can be unknown, left alone. Give me a second. So if A is 0, B can be either 1 or 0. It can be left alone. So my input, like, what is this? This is SC and this is RC and this is SD and this is RT. As you can see in the specifications, I mean in Verilog code, they have given set pins and reset pins for both the flip-flops. So SC, SD, RC, RT. So for the set pin of C flip-flop, it has to be 0, and the reset pin of C flip-flop, it has also to be 0, because let me write it like this: set pin of C flip-flop, reset pin, and set pin of D flip-flop, reset of D. So if a flip-flop is having, if an SR flip-flop is having 0 0 as input, then the output will be in memory state, that is previous state. So this has to be 0 and this as well. As you can see, if A is 0, entire circuit remains in same state, leaving the B unknown. So it can be 1 or 0. So C and D remains in the same state. So if 0, then entire all these pins will be 0. So we need to select some of the options that satisfy this condition. So when it comes to unknown one is SC, set pin of C flip flop. So it has to be 0 if A is 0. So first option cannot be eliminated because it is satisfying the condition. As A is 0, entire boolean expression will be 0, and B is also satisfying, and we cannot take the C because there is no A term, A variable in the boolean expression, so we cannot take C, and we cannot even take this expression as well, so it doesn't depend on A. So we can only select among A and B. So yes, C pin is left with two pins, so I mean two expressions. Those are, one is BD XNOR. So XNOR is having an input of BD, and AC is ungated. So AC is ungated, and this entire two outputs are ungated. And we have another option as well, and that is AC bar. Just C is not gated. So instead of giving C directly, it is negated. And we have the remaining circuit as it is. This is B and this is D, and these both are given to ungate. So SC can be of either this circuit or this circuit. I mean this one. So this combinational circuit can be either these two. So let me just continue with the question. And if A is 1 and B is 1, circuit goes through the transition from 0 0 to 0 1. So initially the circuit will be in 0 0 condition, like 0 0 state. So when it is 1 for both the inputs A and B, the transitions will be from 0 0 to 0 1, and 0 1 to 1 0, and 1 0 to 1 1. So let me write down these transitions. So I have AB. AB is 1 1, and we have the outputs CD. Initially it will be in 0 condition, 0 state, and 0 1 1 0 1 1. So yeah, it is correct. So I need to select among these two such that it satisfies this sequence. So if A is 1 and B is 1, so let me write down the pins. It is 1 and this is 1, B is 1, A is 1. So XNOR gate, one of the input is 1, so it depends on D, and AND gate, one of the input is 1, so it depends on other input, so this will be DC. And we have XNOR, one of input is 1, so D, and this is C bar, so I'll be having DC bar. So these are the possible Boolean expressions. So initially if say 0, it has to transition from 0 to 0. So it is nothing but it is having a same state. So in order to have the same state, we need to ensure that the set pin is 0. So in which condition we will be getting the 0? Initially it is 0 0. So this satisfies to be 0, and this as well. Okay, we cannot decide from this transition, I mean not the D, so we cannot decide this transition. So let's just jump to this transition where C is 0 and D is 1. In this condition I need set pin to 1. Since C is set to 1, so for so 0 1 condition, set pin must be 1, right? So this must be 1. So 0 1. I think this satisfies the transition, right? So instead of DC bar, I could have written C bar T, and this as well to avoid confusion between truth table and these expressions. So this got C bar T. So from 0 1 transition to 1 0, this expression satisfies. So SC will be second option, which is this one. So this is how we got the expression. And if I move to RC, reset pin of C flip flop, I have two options, right? I have AC XNOR with BD pins. So let me write down over here. I have XNOR, B and D are inputs, and AC is ungated. Okay, AC, and this output is OR gated. So this is one of the option, and we have another option as well, that is just not gated C, negated C. So this is B and D, this is OR gated. So in case of A1 and B1, so these will be 1. So if XNOR is having one of the input is 1, so it depends on other pin C, so CD and D, C bar, so C bar D. So if I take this transition, which is 0 to 1, initially it is at 0 state, and when the first clock pulse comes, it will be transition to 1. So 0 0 to 1. Then in order to get I'm really sorry, I got confused. So this is reset pin, right? Reset pin of C flip flop. This transition, sorry, okay, this transition has to remain unchanged. So reset pin must be 0. So this must be 0. So 0 0, so this is 0 and this is also 0, so we cannot determine the exact expression. So let me consider this transition from 0 to 1. So in order to take place this transition, then this reset pin must be 0, which is C is 0, D is 1, right? So if C is 0 and D is 1, this expression is giving out me 1, which is not desired. I need 0. If I consider this, then this gives me 0. So first option is the correct one, and when it comes to unknown 3 and unknown 4, these will be really easy because I can eliminate first option as we have discussed earlier. If A is 0, it doesn't depend on B and it remains in the same state. So I need A in my circuit, not A bar. So this can be eliminated, and I cannot eliminate B option, and I cannot eliminate all these options B, C, D. So let me consider all these expressions. So first option for SD is A B D bar plus A B bar D bar, as you can see. So this can be shortened. We can write AD bar, right? So AD bar. So another option will be AD bar, and we have another option which is AC bar D and AC bar, sorry, AC bar D bar and AC D bar, which gives me AD bar. So these three options, like these three expressions, are giving out me AD bar. So there is no option, like we cannot decide, right? So there is a trick over here. Since they have mentioned that if A is 0, it doesn't depend on B, right? So in this option, as you can see, if A is 0, it doesn't depend on B, right? So we can actually leave this B. We can actually leave this B as alone. We can use A and D or alone. So when it comes to option C and D, my bad. So we can ignore this B option. So among these two, which is C and D, I have chose C because if you can see, AC bar D bar and AC D bar eventually turns out to AD bar, right? So there is no need to include C in our expression. And you may ask that it might affect in other pins, like we may not get the output, right? So let me check the output first. So what is the output? So I have this output. This is D. Wait a second. Let me bring it out here. So this is D. So we have transition from 0 to 1, right? So in order to get transition from 0 to 1, I need to set the D flip-flop fin to 1. So A is actually already 1 and it depends on D, which is actually D bar. So when A is 1, it solely depends on D bar. So it satisfies my transition as well, because initially it is at 0, so it is transitioning to 1, and again when it is 1 it is transitioning to 0, and when it is 0 it is transitioning to 1. So this this satisfies. So option C is correct as of I believe. And when it comes to unknown 4, which is reset pin of D flip flop, so we cannot select the option A because it gives out to be A. So it is not actually true, because if we write down the expression, we have AC bar AC, this turns out to be A, and another option is ABD and AB bar D, right? So I can write it as AD, and another option is A, and the last option is AD as well. So I need this transition to be satisfied, right? So initially it will be 0. So in order to get 1, I need reset pin to be 0. So which is not true in this case. This actually doesn't even change, right? A is 1. So this is not true. And if it is A is 1, this will be D, and this is also not correct, and this is D. So these two options can be true. So among these two, I have selected AD because, as I have mentioned over here, I'm ignoring B. This simply turns out to be AD, right? So these are the answers, and you can easily find this answer. Ripple counter will be having the clock input. Clock input will be previous output, right? So this will be figured out easily, and I don't know how much percent this will be correct. I'm not really sure about this. Please let me know in the comments. And this is undefined because initially the output is unknown, undefined, and this output will only get changed when there is a positive edge of the clock, but initially they have given negative edge. So at the negative edge we cannot have the D input at our output queue, so it will be left undefined, and I can even show you the wave output. So as you can see at the negative edge there is no change in the output, so it remained undefined. Only at the positive edge it has got 0. So, and this is a simple one. You can figure it out on your own. So that's it. Thank you for watching.